Write down the value of sine 30. Okay, so this is only a 1 mark question, so either you have committed your trig values to memory, in which case if you have, brilliant, 1 mark in the bag. If you haven't, this video is fairly long for a 1 mark question, but I just wanted to give you a couple of techniques for remembering these values. So if you're finding it difficult to commit some of these values to memory, then I'm going to show you a couple of ways to help you do that. Yes, you might think, well, it's only a 1 mark question. What's the point in going to all this trouble to learn them? Well, 1 mark is valuable, and secondly, it could be worth 2 on some occasions. So depending on how difficult the trig value is to remember, so it is worth knowing these, or at least having a strategy to remember them. So if you are just interested in the answer here, I will just tell you that the answer to this is a half, which obviously you can write like this or like this. So well done if you did get that and if you know it. If you're interested in watching further now, I'm going to give you a couple of techniques to remembering all the trig values that you will need for a non-calculator paper such as this. Okay, so there is a little table that you can remember, hopefully. Well, I'm going to show you a way of remembering these using a table, which hopefully you will find easy to follow. So if in an exam you've forgotten your trig values, you can literally just do this. So if you write out sine, cos, tan, like this, and then at the top you write across 0. Just trying to squeeze all this in because I've got another example to do on the right hand side. Write that bit neater. 30, 45, 60, 90. They are the numerical values for which you will be asked to give an answer for the trig values. So what do we do now? So I'm going to change colour just so it makes it easier to see. You start off by writing the square root of numbers from 0 upwards for the first line. So square root of 0, square root of 1, square root of 2, square root of 3, square root of 4. And then over that is just 2. So that is the first line done. I'm going to simplify those in a second, and then you'll see where I've got this answer from here. And then for cos, I'm going to change colour again. Let's go for red. So cos, you're going to go the other way around. So starting with square root of 4, then square root of 3, then square root of 2, square root of 1, square root of 0. And again, it's all over 2. It's easy, isn't it, so far? So you don't have to remember much there. Ascending order for the sign, 0, 1, 2, 3, 4, square rooted, all over 2. Reverse, descending, 4, 3, 2, 1, 0, square rooting, all over 2. And then tan is like a little combination of the two of them. What colour should we go for now? Let's go for a purple. You do a kind of combination of the two. So you are doing square root of 0, square root of 1, square root of 2, square root of 3, square root of 4. But this time, instead of over 2, you're doing them over the reverse of the squares. So square root of 4, square root of 3, square root of 2, square root of 1, square root of 0. Get the idea, hopefully. Okay, apologies for my slightly messy square roots there. So the difference with tan obviously is the top line, the numbers are square rooted, and the denominators are the numbers are square rooted as well. So hopefully you can see a little pattern there which might be manageable to memorise. And then if we go to simplifying them, well, this one, sine of 0, well, the square root of 0 is just 0, so the whole of that is just 0. For sine 30, the square root of 1 is 1, so this simplifies to a half, which is why we have got this here. Sine 45, well, it's square root of 2 over 2, if you ask for that value. Sine 60 is as you see it. And then sine 90, well, the square root of 4 is 2. So the square root of 4 is 2, and then 2 over 2 is just 1. So if you asked for sine 90, your answer would be 1. Let's go to the next line. Well, this one here is just a mirror image of that one. So that is going to be 1 as well. Square root of 3 over 2, nothing you can do there, nothing you can do here. This one, square root of 1 is 1, and then 1 over 2 is a half. That is why cos 60 is a half. And then finally this one, again, is a mirror image of sine 0 that we had here. So this one is 0. But you don't need to simplify them. You could just remember the values as we did initially. I mean, I'm just simplifying them to show you where I've got this one from. But you could just leave because it's equivalent value. If you'd have put this, then it would have been acceptable. And then tan. Let's go to my purple. Well, square root of 0 is 0, and then anything involving 0 in this situation would be 0. Square root of 1 is 1, so that is just going to simplify to 1 over root 3. Apologies for the slight squashness here. And then square root of 2 over 2 is 1. And then root 3 over root 1 is just root 3, because root 1 is 1. And then this one is actually undefined because you cannot divide by 0. So we can just cross that one out. So hopefully that's given you a way to remember those values. I'm going to show you where they come from. Yes, we can learn that pattern. If you're interested in actually where they come from, then carry on listening. So I'm going to show you two really important triangles. From which we can derive these trig values. So we've got a triangle. Let's start with the one on the right hand side, this one here. So from this triangle we can get the sine, cos and tan of 45 degrees. Okay, so if you think about it, if you think about your trigonometry, so this is just a unit right angle triangle. What I mean by unit is this length is 1 and this length is 1, so it's a unit length triangle. And by Pythagoras, 1 squared plus 1 squared square rooted gives you the hypotenuse of root 2. And then from that you can get your sine, cos and tan of 45 values, because here sine 45 would be your opposite, which is 1 over your hypotenuse, so 1 over root 2. Your cos 45 would be adjacent, which is 1 over hypotenuse, so also 1 over root 2. And I've just realised I can simplify this to I was going to show you how to do that, but I'll leave it as that for a second. And then tan tan 45 is opposite over adjacent, so 1 over 1, which is just 1. which is obviously what we've got over here. And then the left-hand triangle. So what I've done here is I've drawn, let me just show you using a highlighter. So this triangle here that I'm going around in green would have be an equilateral triangle. The whole green triangle is an equilateral triangle with side lengths 2. I know that you can see a 1 there, but if that was 1, then this length is also 1. Hence, the whole length obviously is 2, and it's an equilateral triangle. If you cut that triangle in half and just get this one here, you can get your remaining trig values from that. So I'll show you now how to do that. So from that green triangle there, you've got obviously your trig from 60 values. So you've got sine 60 is so opposite over hypotenuse, so √3 over 2. Cos 60 equals adjacent over hypotenuse, so half. And tan 60, which is opposite over adjacent, so √3 over 1. I think I probably just need a little bit more room. And then I can also get my trig values of 30. So sine 30 is opposite, which is 1 over adjacent, opposite over hypotenuse, which is 1 over 2, half, again, hence we've got that answer there. Cos 30, which is adjacent over hypotenuse, so √3 over 2, and tan 30, which equals opposite over adjacent. One over √3. Just in case you don't know where I got these values from, again, I'll just go through. So it was an equilateral triangle of side length 2, 2, 2, 2, all the way around, split it in half to give you a right angled triangle with angles 60 and 30. And then if you think about Pythagoras, you'd do 2 squared, take away 1 squared, square rooted would give you your shorter side length of √3, and that's where you got those values from. Okay, hope that's helped. I know that's a lot of effort for a 1-mark question, but I just wanted to show you where the trig values come from. So I wanted to give you a ability to memorize it using like a table type pattern here. But then if you're also interested in where these values come from, this was your explanation for where they come from. You might think, yes, that's a lot of effort for a 1-mark question, but you know, if you don't have some kind of technique, it means you've just got to learn 15 random values. Whereas if you commit this table at least to memory, then you've got a way of remembering them rather than just holding 15 bits of information in your head. Just having this one technique to learn this table would perhaps just get you that final 1, possibly 2 marks, which could be, you never know, could be the difference between a grade. Okay, well done for seeing that to the end.